Okay, the recording has started, and so is the live stream. So did any of you get a chance to look at the previous live session?
The one
I don't.
prior to this, sir?
Yes.
Yes, like I think you covered. Uh,
Yeah, something I covered. So if not, don't worry. First, do let me know whether that is available. If not, I will make sure that you get the recordings to those live sessions or the YouTube link so that you can refresh again. Okay. So in the last class, I was discussing about logistic regression. Right. I'll quickly brush up logistic regression and then get into data envelopment analysis. So what is logistic regression? What is logistic regression?
To find the odds.
Oh, beautiful, right? So last live session, we had a detailed discussion on logistic regression, but let us not spend a lot of time on that. I will make sure you get access to those recordings and please view that. So the few important things is, let me summarize it quickly, okay? So here, your target variable is categorical in nature. What about regression? It is numerical in nature. Your target variable is numerical in a regression, but here it is categorical. You might have two categories, right? Sometimes you might have multiple categories, right? But your category, your target variable is categorical when it comes to logistic regression, which comes under the umbrella of classification. Okay. So, what are important matrices of classification problem? Accuracy,
precision, recall,
okay,
and sensitivity,
yeah,
specificity.
precision, recall. Okay. So accuracy is very straightforward. Precision, right? Whenever somebody talks about precision, you have to ask one question. What is that question?
Positive or negative?
Yes. So precision of the positive class, recall of the positive class, precision of the negative class, and recall of the negative class. So they are different. What is the formula? True positive by true positive plus false positive. What is this? True positive by true positive plus false negative. What is this? True negative by true negative plus false negative. True negative by true negative plus false positive. This is called sensitivity. This is called specificity. This is also called true positive rate. This is, what is this?
True negative rate.
Okay, true negative rate. Okay, so last class we did lot of activities to understand this in more detail, right? So refer to that video, and how to define precision, how to define recall, everything is covered in that class. I request you to watch that video again. So today, what are the additional metrics in classification problem apart from precision and recall and accuracy? Are you aware of any other metrics in classification problems? Right? What is this F1 score?
So it tells the validity of the entire model.
Okay, okay. So let me talk about this particular thing. So I'm giving you a problem, right? Let's say classification of email as spam or not spam, right? Similarly, cancer prediction, yes or no, right? So for this problem, which metrics is very important, precision or recall? Similarly, for this problem, for cancer prediction, which is more important, precision or recall? Can you think about it? Okay, okay. So I'll help you. So before getting into that, what is true positive? What is true negative? False positive and false negative? in this case for a spam email classification?
Sir, true positive is classifying it as spam when it is actually spam.
Yeah. So let's go to this rough sheet. Okay. So here, so I will say y underscore actuals, y underscore predictions, right? So if your actual is spam and you also predict it as spam, it is called true positive. Okay, let me zoom it a bit. Okay, so it's here. Let us call it as tag. Okay, so if this is your actual is spam and your prediction is not spam, what is this called?
False
Yes,
negative.
false negative. Okay, similarly, not spam, not spam, and spam. What is this called? False positive.
False positive. Yeah.
Not spam and not spam will be true negative. Okay, is this clear? This is very important. Without this, we cannot proceed further. Have any doubts on this? Please do let me know. Spam and spam, it's true positive. Not spam and not spam is true negative, right? It is actually spam. You wrongly predict it as not spam, it is false negative. It is actually not spam, but you predict it as spam, it is false positive. Okay. Okay. So let us understand these two in detail. Which is more dangerous in this case? Think about it and tell me which is more dangerous.
Sir, which is not actually spam, but it is predicted as spam. False positive one.
False positive.
False positive. What is false positive? False
Sir,
positive.
maybe an important mail, but it is
Yes.
classified as spam and it goes away to
Excellent.
the
Excellent.
bin.
So that is very important here. Similarly, tell me in this scenario, which is more important?
False negative.
False negative is important because there is a patient who is suffering cancer and you wrongly predict that he is not suffering cancer and he is going to think he is all okay and he is going to go party outside, right? But actually he is suffering cancer. So therefore, in this context, false negative is more important. In this context, false positive is more important. Okay.
Correct.
Right. Here, false negative is important. Here, false positive is important. Now, if you go to the formulas that we have written, precision is trying to reduce false positives. Recall is trying to reduce false negatives because you have it in the denominator. Okay. If you increase precision of class 1, what are you trying to do? You're ultimately trying to reduce the false positives. Is it clear? Similarly, if you want to maximize recall, what is happening? You are trying to reduce the false negative, right? So whenever you increase precision, also please note that precision and recall are inversely proportional. Whenever you try to increase precision, recall will come down, and vice versa. Whenever you try to increase recall, precision will come down. Okay. For some problems, precision will be more important. For some problems, recall will be more important. Is this clear?
Clear.
Yeah. For some cases, what will happen is both will be equally important. Can you think about a case where both are important, precision and recall? Right? Think about it. We'll discuss in the next class. So the formula of F1 score is 2 times precision into recall divided by precision plus recall. Okay, right? So if you want to compute F1, you have to first compute precision. You have to first again compute recall. Only then you can compute the F1 score, right? There is also another formula which is something like this: 2 times true positive divided by 2 into true positive plus false positive plus false negative. This is another formula for F1 score, right? What I will do is I will give you some practice problems on F1 score computation. Okay, I will upload it in the course portal. You will have a section called non-graded assignment, right? Assignment questions on the portal under week 7, I guess. Logistic regression comes under week 7. So I will upload some practice questions so that you can practice this, right? Don't tell me this was not covered. Okay, let me stop sharing for a minute and see how many people have joined. Right, do we have more attendance? Oh, we have more attendance now. I'm happy. Okay, so now I'm going to again share my screen. Right, I'm going to talk about another important concept in classification. What is this? AUC, ROC. Have you heard of this term? AUC and ROC? Okay. AUC is area under the curve. ROC is reporting operating characteristics. Okay. So we will see them in detail. Okay. So, okay. Ignore this column. This is just something like a customer ID, or it is like an index. This has no value. These are the actuals of a logistic regression problem. This is class 0. This is class 1. Hey, can you mute yourself? Somebody is unmuted and I could see a lot of noise. Thank you. So this is negative class. This is positive class. And what are we doing in logistic regression? What are we doing in logistic regression? We are trying to use something called sigmoid function, where we compute sigmoid using this particular formula called 1 by 1 plus e power minus z. Again, if you refer to the previous live session, I would have solved the sigmoid function, and let us not repeat that now in the interest of time. This is sigmoid function and it is going to return probability between 0 to 1, right? That is the beauty of sigmoid function. It will give you probabilities between 0 to 1. Let's say you build a classification model and you get probabilities, right, which is between 0 to 1. You might ask me, why have you given probabilities in increasing order, ascending order? Generally, you don't get probabilities like this. So this is for an example. This is for explanation purpose. I have purposefully taken probabilities in a particular order. Okay. So now I'm going to take something called threshold. What is a threshold? What is a threshold?
So the value beyond which we'll be considering it as positive or negative.
Greater than or equal to threshold will be equal to 1, positive class.
Positive.
Lesser than the threshold, it will be negative class. Is it fine?
Yes, sir.
Okay.
So in this case, so earlier we'll be having something like confusion matrix, but here we ourselves are manually doing it now.
Yes, yes, yes. Okay. So now I am going to keep my threshold as 1. So if you look at this, does any of this value have values greater than or equal to 1? No, right? Everything is 0. Is it correct? Is this probability greater than or equal to 0? Greater than or equal to 1?
No.
No. So it will be 0. So if I have to automate this, I'll give an if condition saying that if this probability is greater than or equal to 1, right, then it is 1, else 0. Okay. So what will happen? Everything will be 0. So now let me take another threshold called 0.9. I'll use the same method. I'll say this equal to if the probability is greater than or equal to this threshold, it is 1, else 0. Okay, so now where will you see a 1?
In the last row.
Last row. Okay. Similarly, I can do this for 0.8, 0.7, 0.6, 0.5. Right, you can drag it like this. Okay, I can do this for all the values from 0 to 1. So here you will have 1, 1 here, right? It's going to be 1, 1 here. Rest all will be zeros. Similarly, here it will be 3 ones, rest all zeros. Okay. So if you look at the master, this is what I have. So this is all zeros. This is all ones. Right? Is this clear? How I derived this threshold table? Is it clear?
Yes, sir.
Okay. So I will copy and paste this here. Okay. Let it be this. Okay. Let it be like this. Okay. So now once we have gotten the classes, we don't need probabilities. So let me hide this. So now let us take these two columns. Okay. Let us take these two columns. Right. I'm going to take it to the right. So I don't want the probabilities. There is actual, there is predicted for threshold 1. What is the tag now? What is this called? 0, 0. What is it called?
True negative.
True negative. True negative. What is this called?
False negative.
What is this called?
True negative.
What is this?
False negative. True negative. True negative. False negative. False negative. Yeah.
Okay. So there is only true negative and false negative. There is no true positive. There is no false positive. Why?
So because there is no positive at all
There
in
is
this
no
threshold.
positive prediction. Everything is 0 here. When you predict everything as 0, you will not have any positive class. There will be either true negative or false negative. Okay. So now true negative is how much? We had 5 true negatives. We had 5 false negatives. Okay. So now if you have to plot the ROC curve, right, you need an x-axis and you need a y-axis, right? You need something called x-axis and y-axis to plot a curve. So x-axis for ROC curve is false positive rate. This is true positive rate. Okay. So now this is when you see the thing numerator and denominator having FP, it will be FPR, false positive rate. This is TPR. Okay. So FP by FP plus TN, right? How many FP we had? 0. False positive was 0. When numerator is 0, your entire false positive rate is 0 for threshold 1. Similarly, what is the true positive here? How many true
0.
positives you had? So this will be 0 and 0 for threshold 1. Okay. So now let us do the same for threshold 0.9. Okay. 0.9, where you only had this as positive. Correct? Only the last one was positive. What is this now? This is one
True
is
positive.
true positive. So what do we have now? We have one true positive, right? And I think there was a reduction in false negative by 1. Correct? Is that correct?
Yes, sir.
Okay. So now let us compute false positive rate. What is false positive rate? How much was FP? 0.
0.
Okay. So if numerator is 0, the entire value is 0. So now let us compute true positive rate. It is 1 divided by 1 plus how much? 4. Correct?
Yes, sir. Because 5 has reduced to 4 since we
Yes.
introduced the true positive.
Right. So do you understand this computation? So you will have to do this for all the thresholds from 0 to 1. Right? If I do that, right, this is what I will end up getting. So for 0.9, it is 0.2 and 0. For 0.8, it is 0 and 0.4. For 0.7, it is 0, 0.6, and so on. And now, after getting this table, what I'm doing is I'm transposing them, right? And I'm having FPR as x-axis, TPR as y-axis. So now what I'm doing, I'm plotting this. So just go to insert chart, you will get this plot between false positive and true positive, right? So this blue line is called ROC curve. Is it clear? Is it clear?
Yes, sir.
Okay.
Sir, in all the cases, like not only to this case, will it be like 0 to 1?
Yes, yes.
No, because in this Excel sheet which we have taken for today's session, we are starting with 0 and 0, and finally it is ending like 1 by 1 to 1.
So that is what our sigmoid function is giving us, right? Between 0 to 1. Whatever we calculate accuracy, it is between 0 to 1. Precision is between 0 to 1. Similarly, this will also be between 0 to 1. So now we saw this blue line is nothing but ROC. So how will you calculate the area under the curve? Okay, let's go back to high school geometry. What is the area of triangle?
Half the base of height.
Half
B
base.
H.
What about rectangle?
B into H.
A into
B
B.
into B into B. So here, do you see any patterns? Is this a triangle? Is this another
Yes.
triangle? Right. So we have 1, 2, 3 triangles. So what is the length? 0.4 into 0.6. Right. 0.6 is the breadth. I mean, is the length, is the breadth, and 0.4 is the length. This is B. Call it A. Similarly, what is this? How much is this? Second one.
0.8.
0.8 is your B. 0.8 into 0.6. What about this thing?
Sir, it should be 0.2, no, sir, because 0.6 minus 0.4.
Yes, you're correct, sir. 0.2. What about this one? 0.4 into
1.
1. So add everything. First one is 0.24 plus 0.16 plus 0.4. What is this?
0.8.
0.8. So 80% is your AUC. So what we saw here, we computed TPR, FPR for various thresholds, and we plotted the ROC curve. From the ROC curve, we computed AUC. Is this clear? Is this clear?
Yes,
Right.
sir.
So logistic regression point of view, you have to be thorough on certain things. Most important thing are the metrics, right? Then how do you infer the coefficients? or how will you explain the coefficients of a logistic regression? So let's take y cap. What is this y cap? Is beta 1 x1 plus beta 2 x2. For now, ignore beta naught. Okay, let us assume it to be constant. Let us not worry about it. Right. Let's have only two features, x1 comma x2. With these two features, you are building a logistic regression model, right? And you are estimating your y hat, and your coefficients are beta 1 and beta 2. Can you define beta 1 and beta 2 for me for logistic regression? Before that, can you define it for linear regression?
So is it something like for unit change in
Yes.
x1, how much will y1
Yes.
y cap change?
Okay. Yes. So let's talk about linear regression, right? If you increase your x1 by 1 unit, right, your y hat will increase by beta 1, assuming x2 to be constant. Similarly, if you want to explain beta 2, you can say something like, for a unit increase in x2, your target variable will increase by beta 2, assuming x1 to be constant. This is linear regression. But now we have something called logistic regression. And in logistic regression, what are we estimating? It is called log of odds, right? What is odds? It is p by 1 minus p, whereas log of odds is equal to log of p by 1 minus p, right? So how do you interpret this? Let's talk about x1, right? For unit increase in x1, right, your target variable will increase by log of p by 1 minus p, assuming x2 to be constant. And if you don't want things to be in log, what you do? You take exponentiation, e power, right? When you take e power log becomes 1, it will be p by 1 minus p, right? For, right? If you don't want things to be in log, you can take exponentiation and you can bring it to p by 1 minus p form. Okay. So again, refer this in the previous live session. We will have a detailed discussion. Okay. So these are the things that you should be mindful about. Logistic regression, right? These are also very useful for from an interview point of view. So many people don't explain AUC, ROC. They stop with precision and recall. If I ask precision recall in the interview, they only say this formula, right? So how do you define precision? How do you define recall? All those things refer to previous live session. So with that, let's get into a very, very important and interesting topic, at least for me, called data envelopment analysis. Okay, let me ask you a very, very difficult question. How many of you gone through the videos, lecture videos? Anybody? At least one person?
Sir, I think DA is from week 8, I guess.
Yeah. Week 9, 8 and 9 are DEA, 10 and 11 are conjoined.
Yeah.
Yes.
That is in
Okay.
that, like we will be defining DMUs and all.
Yes. So can we do DEA today? Or you want to do it in the next week?
Sir, I think for today we shall have a small brief regarding that. I think DA will be relating to that envelopment.
Yes, definitely.
Yeah, this is some product of
Okay.
output weighted out.
So I forgot those two people who joined last week. They promised they will view the lectures and come back today. They say they will be fully prepared for today's class, sir. That is what they promised me today, but I forgot their names. I will catch hold of them. That's fine. So let's start DEA today. Maybe next week also we will quickly revise DEA and then get into conjoint analysis. Okay. Let me share again. Okay. Okay. Data envelopment analysis. What is DEA? Okay. Let us talk about efficiency. What is efficiency?
Weighted output by weighted input.
Oh, okay. General efficiency is output by
Output by input.
input. Okay. Everybody wants to maximize their efficiency. So how will you maximize efficiency? Either by increasing the output or by decreasing the input. Right? There are only two ways by which you can increase your efficiency. We have something called productive efficiency. We will start with some theory concepts. It focuses on maximizing the output under given constraint. What is constraint?
Any limitation of resources upon
Yes.
which the production should be happening.
Yes. Yes. Right. So these are the resources. Some resources you will have in limited number. Within the available resources, how much you can maximize your efficiency. That is what we are looking at. We don't worry about the technology. For example, let's say two people are coding, right? Coder 1, coder 2, right? We want to see who is more efficient, right? There are many ways to be efficient. Let's say this guy is using an 8 GB RAM and this guy is also using an 8 GB RAM, right? And all of a sudden you upgrade this to 16 GB. So what is happening here? There is upgrade in the technology. Whereas in DEA, we don't assume there is technological change. Right? There is no technological change. So within this setting, right, without any change in technology, who is efficient and who is not efficient? That is what we are trying to understand. Right? Let's take a hypothetical example. Let's say there is a car manufacturing company, right? So they are manufacturing 3 cars, right? Creta, Venue, Alcazar, right? So here, let's say you want to maximize output of Creta. You want to increase the output of Creta. If you have to do this, you might have to compromise on the values of Venue or Alcazar. Without this, you cannot achieve it, right? Any questions so far? So if you say that you are on production frontier, that is your efficient, you are on the envelopment, increasing 1 unit, increasing 1 unit of production of Creta is not possible without compromising on the production units of Venue or Alcazar, right? These are some theory concepts that are good to know, but we will focus more on the important aspects, right? I mentioned 2 things. One is reducing the input or increasing the output. Let's say this is IP1, input 1, input 2. This is right. So let's call this 1, 2, 3, 4, and 5. These are 5 DMUs. What are DMUs? Decision making units. They're also called economic units. What else? Business unit, economic unit, decision making unit, DMUs. These are used interchangeably. Decision making unit, economic unit, business unit. Everything refers to business units. Okay. So which are efficient here? Which units are efficient here? 1, 4, and 5. They lie on the envelopment. They are very efficient because they are using lesser inputs. Similarly, here, this is output 1, this is output 2. 1, 2, 3, 4, 5. These are efficient, right? DMUs 1, 4, 5 are efficient because they are producing relatively more output in comparison to 2 and 3. Okay. So DMU measures relative efficiency. So why is it very important? So let's take a cricketing example, right? In cricket, let's take Kohli, Virat Kohli, and Sachin. Can you compare Virat and Sachin in cricketing numbers? Right? So how will you measure efficiency of a cricketer? First of all, tell me that.
Like strike rate.
Yeah, we'll have lot of things, right? You have average, number of hundreds, strike rate, 50s, number of fours, number of sixes, number of matches.
Number of balls faced also.
Yes, it's very, very important in test matches. Right? Balls faced, right? So Virat will have very different numbers. Sachin will have very different numbers. But how can you compare them in one scale? Right? It is like comparing oranges to apple. That is why when people compare Kohli to Sachin, they say it is very wrong. It is very, very wrong. You cannot compare them in a absolute scale. Therefore, you can compare them in a relative scale. That is what DEA is doing. So there are different outputs and inputs, right? What are the inputs here? This is an input. This is an input. Average could be an output. 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 You can have more inputs, right? Many of us are not experts in crickets, right? So these are some of the inputs. These are some of the outputs, right? If you take person like Rahul Dravid, right? He will be good in certain things, right? For example, he is a champion in this particular metric, balls faced. Okay,
Because he's the wall.
Yes, he's the wall. Okay. Similarly, when it comes to Sachin, number of matches, right? He's beyond anybody. Okay, when it comes to number of matches. Kohli, when it comes to strike rate or sixes or something else, right? What is that? It could be hundreds, something. Okay, in test match, Kohli is better. In one day, Kohli is slightly better. Sachin is very good in test matches and so on. So each person can select his or her own inputs and outputs. Okay, so Kohli, if you take Kohli, right, he will focus on certain inputs, not every input. Kohli could be good in some, may not be good in some. He is going to selectively choose inputs and outputs so that Kohli's efficiency is maximized. Is it okay? Right? It is going to be something like U1O1 plus U2O2 divided by W1I1 plus W2I2, and there are many inputs and many outputs. So what is the first output Kohli will choose? Things that will maximize his efficiency. Second output, again, things that will maximize his efficiency. For example, if Sachin Tendulkar will not, Rahul Dravid will not focus on strike rate, right? He will give very less weightage to strike rate. He will give more importance to number of balls faced. Similarly, Sachin will give more weightage to number of matches, number of hundreds. He will give less weightage to number of sixes. Is that correct? Are you with me? Are you with me so far?
Yes, sir.
Yes, sir.
Okay. So now there will be three problems we are going to solve. One for Kohli, right? One for Sachin, one for Dravid, right? And what are we trying to do here through data envelopment analysis? We are going to compute the weights of Virat Kohli, right? So the weights of Virat, weights of Sachin, weights of Dravid. Let's take Virat's example, right? We will solve a DEA problem for Virat Kohli and check whether he is efficient or not. Okay, so far with me? And how will you check it? Right, you have weights, you have inputs, you have outputs, right? U1 I1 plus U2 I2 by W1 Just a second. U1 O1 plus U2 O2 divided by W1 I1 plus W2 I2 and so on, right? You will solve the DA problem for Virat. And what are you computing here? The weights, output weights and input weights. And then you check whether Virat is efficient or not. Is it fine? So far with me?
Sir, but one thing here we are saying like each player has their own advantages and
Yes.
strength. So
Yes.
each will be having their own weightage.
Yes.
But say if I'm assigning weight for each of the 3%, I'll be giving some weightage.
Yeah.
And if you are giving some weightages, it will be different from mine.
Yes.
But
No. I will tell you. So now first we will go step by step. Let us not complicate things. First we are solving the problem for Virat. Okay. And we will find the weights where Virat is maximizing his efficiency. We will find weights. We will take the outputs and inputs where Virat will maximize his outputs. Right? We will take all the inputs and outputs. The only thing that vary is the weightage that is given to the output and weightage that is given to the input. Virat will focus more on sixes. Virat will focus more on number of hundreds and so on. Okay. Then we will check whether Virat is efficient or not based on the weights we have derived for Virat. So far with me?
yes, sir.
Now use the same weights that Virat used. U1, U2, I1, I2. Check whether Sachin is efficient for the weights of Virat. Okay. Now what are you doing? You are taking the weights you computed for Virat, and then with that weight, you are checking whether Sachin is efficient or not. Okay. Similarly, next what you will do? You will solve the DA problem for Sachin. Sachin will try to maximize his efficiency by giving weightage to the outputs and inputs so that the efficiency is maximized. So now we will find the weights for Sachin, U1, U2, I1, I2. Check whether Sachin is efficient or not. And then using the same weight, you can again go to Virat and check whether he is efficient for the metrics of Sachin. You can go to Dravid and check whether Dravid is efficient or not for the weights of Sachin. So now what are we trying to do? We are leveling the game. It is no more apple to orange comparison. It is apple to apple comparison. And to give you some interesting facts, a professor from IIT Madras, he worked on this DEA. He took all the data from Cricinfo. He solved this DEA problem for Virat, Sachin, and Dravid, and all of them were efficient. For Virat's metrics, Sachin was efficient. For Virat's metric, Dravid was efficient. Similarly, he solved a problem for Dravid. Virat was efficient. For Dravid's metrics, Sachin was efficient. Right? So similarly, you can do this in your company, right? So if there are 3 sales officers, which is efficient, which is not efficient? If there are 3 teams, who is efficient, who is not efficient? Right? You can do this in a relative scale. Right? Is it okay?
Sir, so it will be like comparing one car with the other car, or one car within the same subject, something like that.
Okay.
So rather than having an absolute value, which is impossible, we are going with this method, right now, sir?
Yes, you are leveling the game. Each and every car is good. Right? If you take this example from a car point of view, let's compare. Which cars can we take? Right? Okay, let's take 3 sedans. Right? You have Honda, Honda City. Right? Honda City. We have Volkswagen Virtus. What else? One more sedan. Skoda Slavia. Right? We have these 3 cars. These 2 are more or less same. We cannot compare, but let's take a hypothetical example. Assume these 2 are different. Okay. So Honda will be good in engine. Right? Honda will be good in engine. These 2 will be good in transmission. Right? Similarly, Honda might be good in service. Okay. They might be cheaper in service. This could be expensive, right? So Honda will select weights so that it maximizes its efficiency. Whereas, I mean, this is not a good example. You can, this will be more suitable in conjoint analysis. When you compare three cars, right? It will be more suitable in the next topic, which is conjoint analysis. But nevertheless, we can also try it here. So Honda will try to take inputs and outputs. This is the cost price is cheaper. This is expensive. What else we can? Maintenance. Brand value. Resale. So you have a lot of parameters. You can classify someone as input, something as input, something as output, right? And then check which is more efficient. For Honda's metric, you can check whether Honda is efficient or not. It is not necessary that if you take Honda's metric, Honda will be efficient. So there could be a case where Honda itself may not be efficient. It may not have an efficiency of 1. It might have something like 0.6 or 0.7. Right? Even for its own metrics, it may not be efficient. But for Honda's metric, Volkswagen could be efficient. Right? This is just a introduction to data envelopment analysis. It's a very, very amazing topic where you could do a lot of research. Somebody can take up your bachelor project on this particular topic. It's very, very rich, very unique. Right? It's a very, very in-depth topic to be analyzed. So right now we are only introducing data envelopment analysis. Don't think that this is the ultimate data envelopment analysis. Is it okay? Okay, we have few more things to cover. Let's understand them. So here, the data envelopment measures relative efficiency that calculates individual efficiency for each DMU when there are set of DMUs available. So here, what makes this very complicated? We don't have one input and one output. We have multiple inputs, we have multiple outputs, right? For example, if you take W1, I1, W2, I2, so this could be something like 10, 100,000. This could be something like 8. This could be salary. This could be years of experience, right? These two are very different. These two metrics are very different. So what makes this challenging is the nature of inputs and outputs, the number of inputs and outputs. That is why it is very difficult. You don't have a straightforward problem. You have a very complicated problem. And that's why we need more sophisticated techniques. So solution, we are solving a DEA problem. We are using linear programming method where we want to identify the optimal weights of inputs and outputs. Inputs and outputs. Is it fine? So whenever you talk about linear programming problem, what are the things that you should be aware of? Objective function,
Constraints.
decision variables.
Response
I think
variables.
so. This is number 1. This is number 2. Constraints. Then there is something called non-negativity constraint. Okay. So 4 things should be there. Okay. So what is the important constraint in a DEA problem? Your efficiency cannot be greater than 1. It can be equal to 1. It cannot be greater than 1. Efficiency has to be always lesser than or equal to 1. It cannot be greater than 1. Not just your DMU, all the DMUs must have efficiency less than or equal to 1. Is this fine? Is this fine?
Yes, sir.
Okay. So the efficiency here is Y1K O1K plus Y2K O2K so on ymk omk divided by x1k i1k plus x2k I2k plus dot xnk plus ink. Okay. So this is what is this k? So if you have Sachin, Virat, and Dravid, how many k's are there? K will be equal to 3. So 3 decision making units, 3 business units, or 3 business units. So k will be 3. For each and every one, you have to solve a separate linear programming problem. So can you solve a linear programming for this particular objective function? Can you maximize EK? Will this be linear programming problem? Right? What is linear? Is this linear? This is not linear. This is a ratio. You have a numerator, you have a denominator. It becomes a non-linear programming problem. But you don't know non-linear programming problem. We have not introduced NLP, non-linear programming. The only thing we know is linear programming. Linear means if this increases, this will increase linearly. Okay. So now you have a complicated function which is non-linear. So what is the first step? Linearize the objective function. How will you do that?
Maximize the numerator
Maximize the numerator.
and normalize the denominator.
Okay, maximize numerator. Normalize the denominator means set the denominator equal to 1.
Less than or equal to 1.
Okay. So how will you do that? You have a numerator, you have a denominator, right? You are trying to maximize the efficiency and you know that the efficiency cannot be greater than 1. It has to be lesser than or equal to 1. So now what we will do is we will only maximize the numerator, and if you cross multiply, you can have a constraint saying that numerator should be less than or equal to denominator, right? So now you will have only this thing on the objective function. You're maximizing only the numerator. What happened to the denominator? You have set the denominator equal to 1. And you have also placed the constraint saying that numerator is less than or equal to denominator. Is it fine? Is it fine?
Yes, sir.
Yeah.
Okay. So now we will, we are already out of time. Can we continue for a few more minutes or shall we do it next week? Was it heavy? Will you also look at videos and come next week? Can we stop?
Sir, that's what. How do we search there? Because when Dr. Milo was taking, he used to put September 25, session 1, session 2, session 3.
Okay.
I just want to know how these videos, the ones that you are taking, are saved.
Okay.
In the YouTube.
Whatever Milo was doing so far, I will include this in the same channel. Okay. So tomorrow, my last week's session and this week's session will be uploaded on YouTube. Okay, in the same channel.
Sure, sure.
Okay. So let me do one thing. We are already running short of time. Already few people have ran away. Note down their names. Okay. We will take action. Let me stop my live streaming now, and I'll be here for a few more minutes to answer some questions. Okay.
Sir, can I ask
Okay.
a question related to previous week's content?